Well, good morning everybody. It's time to start packing the mold for the intake manifold. I just start off with a little sand with it inclined like this, and I'll do it in a couple installments here, but no big shakes, nothing too interesting about this. Just basically fill it up carefully and turn the vibration on. Back in a couple seconds. Okay, I got the sprue glued on there. I thought you might like to see some of the action from vibration, so I'll try to turn the volume down here so I don't blow you out. Here it goes. You can see I put the second flask extender on and filled the mold up right even with the top of the sprue. So now it's time to install the pouring cup. And the pouring cup, it's got a big target here on the top, and it's an offset pouring basin with a weir, little dam down there in the bottom of it. I think you can probably see, and a square opening for the sprue. So I just sit that on top of the sprue, like so. Wedge it on there a little bit. So it's fairly secure. And now I'll just fill the rest of the flask up with sand, and this mold will be ready to pour. Back with you in a couple. All right, back with you. I filled the mold up the rest of the way. The pouring cup's in place. Hit it with some vibration. Took almost all the sand I had in the house. There must be, I'd say easy 400 pounds of sand sitting there in that flask. It's 16 inches in diameter and about 4 feet tall. So I plan on pouring it from this side here, just in on the side at the back end of the pouring basin, and hopefully all goes well. I'll be back with you shortly. We'll take a look at the setup for making the pour. I had to build some lifting equipment and a few other things, so we'll talk about that shortly. Back soon. All right, back with you. Got everything staged, ready for the pour. Thought I'd just take you through a quick trip through the pieces of gear that I'm using to make this pour. So the pour I expect to be, I've got a 40-pound charge in an A60 crucible. You see I built myself a little gantry crane, a little light-duty gantry crane there. I'll try to put a link into that, but at thehomefoundry.com there's a link to that build, as well as all the other equipment. So let's take a look at what we got here. Besides the gantry, you can see that there's an electric hoist hanging on there, and attached to that hoist is a shank. So let's go have a look at the shank. And here is the shank. And the shank has got movable jaws, or jaws that open, and that handle on the back is an over center device that runs down the center of the rod of the shank that opens the jaws of the shank, and that's how you grab it. The jaws clamp on it, and they're curved and they capture the crucible. Then of course the hoist is there on rollers on the beam of the gantry, and to control the hoist I've got a little switch here where my back hand is, and then to just make it a little bit more maneuverable, I put a little tail shaft on it to put some counterweight, because it gets kind of nose heavy with this 40-pound charge of ingot in there that's all virgin A356 ingot that I cut up and put in there. And then the furnace, as you can see, is a lift-off furnace. It's got counterweights that help lift everything, but I'm able to take that crucible and stick it in the opening there of the furnace and release it, and I can snatch and pour it all in one motion with the lift-off furnace. And under the gantry, I've got the mold that we just packed. You can see it's top of the mold is right at 4 feet off the ground. I got an ingot tray situated there by the mold, so I can dump out the residual after the pour. Those two rods that you see sitting on there are master alloys, strontium and Tibor, which grain modifiers and things that will work well with silicon alloys like A356. So I've got them. I figured I may as well use them. And outside of that, on the furnace, that lower section that you see is an 8 kilowatt resistive heating insert. This furnace I originally designed to be fuel fired, but since I'm just melting aluminum and I've got the most experience with using resistive electric and getting very good results with it, I just decided to use the electric insert on that as opposed to putting a burner in there. So you can see on the plinth at the bottom, I've got a sacrificial piece of cardboard because on one of my test runs when I melted some scrap, the plinth actually stuck to the crucible, which was a bit of a problem because the opening of the furnace isn't quite tall enough to easily accommodate that A60 with a plinth stuck to it. So hopefully this will prevent any stickage on that. Then as far as the furnace, you can see these counterweights here. And what I've got to make the furnace lift is a linear actuator. You can see it on the back side there. And I just run that with a little 12-volt battery and a switch up there in the top. And it's got limit switches at the top and at the bottom. And then here, you can see on the back, is my contact pyrometer. I just stick that in the vent lid, and I'm able to measure the molten metal temperature with that. And of course I got a little skimming spoon hanging there as well. So that's pretty much the whole apparatus here. I zoom back. I don't think I forgot anything, but yeah, so I'm going to flip the switch, and hopefully the next episode here will be me actually pouring that monster. So stay tuned. All right, everyone, the moment of truth here. I've added the grain modifiers and refiners, the strontium and Tibor, and done the final skim. We're at pouring temperature, so it's time to pour a bunch of metal on a bunch of foam and see what happens. So I did invest in a respirator because this big a pour, I didn't know, I hope I'm not, but if I'm standing in a cloud of polystyrene smoke, I need to stay in the fight. So I'm going to wear it and get at it. So let's see how it goes. Well, I think it went pretty well. Near as I can tell, it took the amount of metal that it should have, so that's a good sign. Boy, I tell you, it really started taking metal fast on me. I think I kept up with it, but it's hard to tell because the cup's so high, I can't see the bottom of the cup. But I just kept pouring on that, and so we'll see. We'll know in about 15-20 minutes here when we demold it. So stand by. All right, I'm back with you. Now it's time for the real moment of truth, demolding. I'm going to try to get that top extender off and let the sand fall to the ground, because that thing is going to be really, really top heavy, and I don't know if I can control it from crashing into the ground. It's 400 pounds and most of it is above the pivot, so if I could get that top flask off there and let the top foot and a half of sand fall to the ground, that'd probably get 150 pounds out of it. So that's what I'm going to be doing, trying to work that off there first, and then I'll just dump the whole thing on the ground, demold the part. Stay tuned. Well, that thing's quite the chunk to yank in and yank out of there. You know, from what I could tell, it looks whole, but you never know until you get the refractory off and take a good close look to see if there's any flaws. But the good news is, it looks like an entire part. Won't know until I examine it a little closer, but I'm going to spread this sand out, let it cool off, and clean it up a little bit, get a better look at it, and I'll rejoin you after I do that. Thanks. Well, back with you. I cut the sprue off, and I think we've got a mostly formed part here. It does have some flaws, namely in the way of some what I call leakers, that where the mold has become destabilized. This side, all of the intake runners look very good, but it's because this was the side where they all kind of ran downhill in the mold. But here on this side, you can see those don't look so good, and they were the ones that kind of had to flow backwards and uphill. And the bottom line in all this is I just don't have enough vibratory energy in my rig to shake 400 pounds of sand. So the good news is if I zoom in on this, I may be able to salvage these over here in this runner, because you can see I've just got under that with the edge of a chisel. And the one thing about these things that I call leakers is the refractory coating is still between where the pattern was and where the destabilized mold is, and usually you can work those loose. So I'm going to spend a little time on it and see if I can work those loose, and if I can, it may be a perfectly serviceable part. But it's going to take a little time and energy to do it, but hey, we come this far. Why not, huh? All right, well, let me work on it for a while, and I'll be back with you. Well, hello, everyone. I'm back with you, and I spent some time thinking about what to do about my casting here, but maybe just to summarize, pretty much all the exterior features cast very nicely, and most all of the interior features, except I had this metal intrusion on this one bank of runners, and this other bank of runners, they were just fine. So I guess I chose very poorly in how I chose to position the pattern in the flask. And I aggravated that with a couple of things in how I packed it and everything that went into destabilizing the mold. But the bottom line here is that the amount of metal intrusion into the runners, it's just too big for me to break loose. Now, sometimes I mentioned earlier, this is an example here of a piece that was laying in one of the runners, and you can see that was the piece that was laying against the runner wall. So the refractory actually did isolate it, and I popped that whole thing out of there in just one piece like that, just by wrapping it. And that kind of gave me some false hope that I beat the living piss out of the edges I could get at on the big chunks that are on this, what were the upstream wall. If I were to orient it, this would have been positioned in the mold like this, with the carb openings, you know, down at a little bit steeper of an angle. I'm not going to be able to get that in the video screen for you, but you get the idea that these openings were actually inclined and facing down or downward in the flask, and these actually are the ones that the runners, the angle of the runners run uphill on that. So the combination of these facing downward and it being uphill led to some pretty poor packing. That was a pretty poor decision on my part. So I suppose somebody could try to grind out all the metal intrusion like a big porting project, but there's sand on the surface of that. You probably munch, you know, maybe 10 or a dozen carbide burrs, you know, trying to get through all that. And my objective here isn't to rework a single manifold. It's to be able to cast, develop a process to cast not only this manifold, but a number of other very similar manifolds to it. So I'm just, I'm going to bite the bullet and make another pattern. So I guess for those of you following along, that means that you've got a part 3 to this series to look forward to. It'll be me taking another shot at casting a net-shaped part that looks just like this one. So stay tuned for all of that. And again, if you would like to see build threads on any of the equipment that was shown in the pour, my furnace, the lifting apparatus, the pouring cup, any of that stuff. There are very detailed build threads with lots of pictures at thehomefoundry.org. Please consider joining there. I put a lot of effort into documenting those things in those threads on the forum. They're easy to find. I'll be happy to direct you to them if you're interested in seeing them. Otherwise, just stay tuned and look for part 3, and we'll have another go at this. Thanks for watching.